Hello and welcome to the live broadcast of our first Electron mission for 2020. It is 15:41 New Zealand Daylight Time at Rocket Lab's Mission Control Center here in Auckland, New Zealand. I'm Max Muncy, and I'll be with you throughout today's live broadcast of our 11th Electron launch, a mission that we've called Birds of a Feather. Liftoff is scheduled to take place at 15:56 New Zealand Daylight Time from Launch Complex 1 on New Zealand's eastern coast. Conditions are looking great for today's mission, and we're continuing the countdown to launch with all systems currently nominal. This is a live view of our Electron rocket, which is a carbon composite liquid-fueled launch vehicle equipped with 3D printed electric turbo pump bed engines. Our first launch of Electron took place in May of 2017 from this very pad. Fast forward to today, and we've conducted 10 Electron launches, deploying 47 satellites to orbit for our customers. Today we're excited to be on the pad for our 11th Electron mission, a dedicated launch for the United States National Reconnaissance Office, also known as the NRO. Headquartered in Chantilly, Virginia, the NRO develops and operates unique and innovative satellites to meet national security needs. NRO satellites provide U.S. government and policymakers with global situational awareness, signals intelligence, and near real-time imagery. The mission was awarded under the NRO's RASER, or Rapid Acquisition of a Small Rocket Contract Vehicle, which enables the NRO to explore new launch opportunities that can provide a streamlined commercial approach for getting small satellites into space. Each Electron mission is given a unique name and patch which represent different elements of the mission. This launch has been named Birds of a Feather, and the patch features a kiwi bird meeting a bald eagle just off the coast of Launch Complex 1. This mission also has a second patch designed by the NRO. For 6 decades, the NRO has answered the hardest national security-related questions with bold, innovative technology, and this mission stands firm in this tradition. The logo is a lighthearted way to wish NROL 151 good fortune on its mission. As we hit T-minus 12 minutes into the countdown, let's take a closer look at some of the NRO's work. It's an honor to be flying this mission for the NRO. The data collected by the NRO is used to support a variety of military and civil operations, such as keeping U.S. and allied forces out of harm's way, as well as supporting civil agencies to assess devastation caused by natural disasters, such as hurricanes and wildfires, and to assist with the associated relief efforts.
Okay, VMS flight mission.
Go ahead.
Please confirm all separation events are armed.
Confirmed.
RF flight mission.
Go ahead.
Confirm S2S band has been switched to high power for flight.
Confirmed.
And please bring stage 1 S-band to high power and confirm.
Confirmed.
Avionics flight mission.
Light avionics.
Please cycle vehicle camera recordings and confirm.
Confirmed vehicle camera recordings have been restarted.
GC flight mission.
Go flight.
Please enable ground high-speed logging and vibration logging.
High-speed logging and vibration logging enabled.
And GC, please confirm with that with the range.
Rocket Lab's mission is to open access to space for small satellites. Not only do small sats provide vital services to all of us down here on Earth, but they also enable innovation, research, and exploration in space. Now, opening access to space relies on frequent launch, and a great way to fly frequently is by having a reusable rocket. Last year, we announced our plans to recover and refly Electron's first stage booster on multiple missions, and if you watched our last launch in December, you'll know that we're getting closer to making this goal a reality. Our 10th Electron launch saw us carry out the first guided re-entry of Electron's first stage. This is a key test of the new reaction control and guidance systems that helped us understand Electron's descent back to Earth. What you're seeing now is footage from onboard the stage as it was traveling back to Earth at around 8,000 kilometers per hour. This Electron stage made it all the way to sea level intact, proving that the vehicle is capable of surviving the harsh re-entry environment. For today's mission, we'll be carrying out a similar test with some refinement to the guidance systems to further analyze Electron's descent. Once again, the stage will not deploy a chute and will not be recovering the stage. Instead, it will undergo a planned impact at sea. We do have a camera on board the stage that we'll cut to during this broadcast and stick with as long as we can, but we do expect to lose that video link at approximately 30 kilometers altitude. You may see some light blue glow or plasma from this feed, or even a reddish glow around the vehicle as the stage heats up upon descent. This is normal as an expected part of the reentry process. The project lead for Electron's reusability program is Alex Lanassier, and we spoke to him recently to see how the project is progressing.
My name's Alex Lanassier. I'm a special project engineer here at Rocket Lab working on the Stage 1 recovery project. What Rocket Lab really wants to do is open access to space. A way that we can avoid having to build as many rockets and allow us to launch even more frequently is to recover the stage, recharge it, refuel it, and send it back up again. So as a small launch vehicle, Electron doesn't have the margins that some larger launch vehicles have on them, which means that we can't do things like propulsive landing. This means that we have to design systems that have to operate in very extreme environments, but are lightweight and a very efficient use of volume. The real difficult part of this is not actually catching the stage or getting it back, it's getting it through the wall in the upper atmosphere. So Flight 10 had some new systems on board. Everything we can use to sort of verify our modelling and learn about what the stage is actually doing. So these sensors collected an incredible amount of data that we were able to sort of reconstruct the trajectory and show that the Stage 1 from Flight 10 actually made it down to the water intact. So Flight 11 has very much the same architecture and systems on it as Flight 10. What we've done is change the configuration of the system so that we can try and capture video footage all the way down to splashdown. On Flight 10, we got confirmation that the stage made it to the ocean intact. And from Flight 11, what we really want is this visual confirmation of that. After Flight 11, once we have that data set and the data set from Flight 10, what we're going to start doing is adding systems onto the rocket that actually allow us to recover the rocket. Flight 10 is probably the thing that we're most proud of. The fact that we designed this system, got it on the rocket within 4 months from initial concept to launch, working with pretty much every single team across the company, and had the system perform absolutely flawlessly first go and gave us even better data than we expected.
The crew down Mahia have a tight schedule to meet on launch days, and today was no different. The day's campaign began early this morning at around T-minus 12 hours, as launch technicians rolled Electron out of the vehicle facility down to the pad before the strongback lifted the vehicle to a vertical position for launch. Approximately 5 hours before T0, we begin fueling Electron with a highly refined kerosene, and then at T-minus 3 hours, we fill the vehicle with roughly 9,000 kilograms of liquid oxygen. Throughout this time, our team at Range Control are monitoring minute-by-minute weather conditions, including the ever-present threat of upper-level winds, as we count down to T0. At about T-minus 18 minutes, our launch director conducts a go, no-go poll with the operators to confirm that Electron is ready for flight. This includes a check that all of the rocket systems are good to go and that the weather is clear for liftoff. At T-minus 2 minutes, Electron's auto sequence begins and the flight computers take over the launch countdown. After T0 ignition, it takes about 2 seconds for the Rutherford engines to lift Electron off the pad. A little over a minute into flight, approaching an altitude of 12 kilometers, Electron will pass through maximum aerodynamic pressure, or max Q. This is the point in flight where the forces on the vehicle are at their strongest. You'll hear the call for max Q from our guidance and navigation team and mission control, but if you watch carefully, you might actually catch a glimpse of its transit. Shortly before the moment of max Q, while the vehicle is transonic, a cloud of condensation known as a vapor cone will form around Electron. This cloud is a physical effect of the vehicle traveling so fast, around 1,500 kilometers per hour, that the moisture in the air surrounding Electron condenses and creates a vapor cone. 2.5 minutes into flight, all 9 Rutherford engines on Electron's first stage will shut down and the booster will separate. At this point, the first stage will begin its descent back to Earth, a journey that will be monitoring closely in line with our recovery efforts. After stage 1 SEP, the vacuum-optimized Rutherford engine on the second stage will ignite, propelling the kick stage and the payload into orbit. Fairing separation will occur shortly after stage 2 ignition. 9 minutes after liftoff, Electron will be orbital and the second stage engine will shut down in the lead up to kick stage separation. After separation, the kick stage then relaxes into an elliptical parking orbit around the Earth before lighting its Curie engine 52 minutes into the mission and then moves into position for payload deployment. Today's webcast will conclude shortly after kick stage separation, so there won't be footage of this payload deployment. So now you know what to expect from today's mission, and with just 3 minutes left before the liftoff, let's hand it over to mission control to hear the final count.
Okay, and all stations, flight on mission code from now on, there should be no red flags in your LCCs. And I can confirm vehicle is now green, ready for flight. VMS flight on mission.
Go ahead.
Please confirm flight computer as goes green.
Confirmed.
VMS please lock auto sequence and confirm.
Auto sequence is locked.
Copy that, and all stations be advised we are currently go for auto sequence at T-minus 2 minutes, commencing in 30 seconds. Okay, avionics, flight on mission code.
Avionics.
Please confirm all AV bats have been switched to internal power.
Confirmed all AV bats are in internal power.
And confirm stage power is disabled on all 3 stages.
Confirmed external power for all 3 stages is disabled.
All stations be advised vehicles now on internal power. PLS flight mission.
Copy.
Please begin lock skid reset.
Researching.
Pressing Kero.
PLS flight on mission.
Copy.
Please disable anti-geysering and confirm.
All anti-geysering disabled.
Stage 1 flight mission.
Stage 1.
Confirm stage 1 is pressed.
Confirmed.
Stage 2 flight mission, same to you.
Stage 2 is pressed.
Thank you.
High flow engine purge active.
Enabling deluge.
Deluge running.
Setting GNC states. Re-readying engines.
Ten, 9, 8, 7, 6, 5, 4,
Ignition.
3, 2, 1.
Stage
And we're
1
off the pad.
propulsion
We are
nominal.
T plus 35 seconds into flight for the 11th Electron mission. In approximately 30 seconds, the rocket will reach the point of maximum aerodynamic pressure on its way to space. So let's listen in for the call from Mission Control.
High voltage battery discharge nominal.
Electron is supersonic. Approaching max Q. Cleared max Q.
An Electron has cleared max Q. Next up is a series of mission milestones which occur in quick succession. Coming up first is main engine cutoff, or MECO, followed shortly by the booster's separation from the rest of the vehicle. When this happens, we'll cut to a view of the booster's ascent to Earth as Stage 2 continues onwards. First, let's check back in for MECO and stage separation.
Speed is 1 kilometer per second. Altitude is 26 kilometers.
AOS at Chatham Station.
Stage 1 propulsion remains nominal.
Electron's
We
Rutherford
have
engines are
MECO in
continuing
approximately
nominally
30
on the way to
seconds.
orbit. Our speed is currently 4,800 kilometers per hour, and our altitude is 45 kilometers as we approach main engine cutoff.
"20 seconds remaining.
Stage 1 MECO.
Stage 2.
There you have it. We've had successful MECO, and Electron's first and second stages have separated
Stage
cleanly.
nominal.
In the screen on your left, you'll see the first stage begin its descent. We'll leave this camera up for as long as we have it for you, but we do expect it to cut out, and we should see jettison of Electron's fairing very shortly.
Separating fairing.
And there it is on your screen. The fairing has separated, clearing the way for
Stage
payload
2
deployment.
propulsion's nominal.
A quick update from Mission Control. We're currently T plus 3 minutes and 48 seconds into flight, and Electron continues nominally. We're lucky to see some fantastic views of Earth from up here in space as Electron's second stage Rutherford engine continues to propel its payload to orbit.
High voltage battery discharge nominal.
Stage 2 guidance is nominal.
A quick update from Mission Control. If you're just joining us, we've had a successful liftoff of the Birds of a Feather mission for the NRO. We saw a successful cutoff of Electron's
Stage
Stage
2
1 engines
propulsion's
and a
nominal.
clean separation and ignition of Stage 2. Velocity is currently 11,600 kilometers per hour, and our altitude is 180 kilometers
Speed
at
is
5 minutes and 6
2.4
seconds into
kilometers
flight.
per second.
The next mission milestone coming up is the battery hot swap. Electron's batteries are nearing depletion, and in order to continue on the journey to space, we need to swap over to a fresh power source. So let's wait for the call from Mission Control.
Throttle down.
High voltage battery discharge nominal. Approaching hot swap in roughly 30 seconds. AFDS has saved.
Hot swapping.
Hot swap successful.
As you've just heard, we've had successful battery hot swap. Electron continues to look nominal as we hit 6 minutes and 36 seconds into this mission.
Stage 2 propulsion is still holding nominal.
Two minutes remaining.
All systems are nominal and Electron looks healthy. We're currently 7 minutes into this mission as we look ahead to second engine cutoff in approximately a minute and a half.
90 seconds remaining.
High voltage battery discharge holding nominal.
Coming up next is stage 2 engine cutoff and kick stage separation.
50
This
seconds
point will mark
remaining.
the end of the vehicle video feeds from this mission. So let's listen in for the call.
Entering stage 2 burnout detect mode. Ten seconds remaining.
And seek confirmed.
Stage 2 separation.
And that confirms Electron's second stage engine has shut down as planned. The kick stage and the second stage will now separate for the final push to payload deployment.
We're in a good kick stage orbit.
And there you have it. Kick stage separation has been confirmed. Approximately an hour from now, the kick stage will deploy the payload to orbit, marking the completion of today's mission. Stay tuned to our social media channels for confirmation of payload deployment. But before we close out today's webcast, a final thank you to the NRO for selecting Rocket Lab as your mission partner. It's been an honor to fly you on board our 11th Electron mission and our first launch of 2020. We've got plenty more to look forward to this year, including our upcoming first launch from U.S. soil in Virginia and our big move to our new headquarters in Long Beach, California. Don't forget, we're always on the lookout for fresh talent here at Rocket Lab. If you or someone you know would like more information on the roles that we're currently recruiting for, head to rocketlabusa.com. So thanks for watching, and we'll see you again here soon. I'm Max Muncy. This is Rocket Lab Mission Control signing off.